Welcome to a new exercise. This time we're going to learn the differences between average velocity and average speed, and also between distance and displacement, all in a single exercise. So buckle up and let's have a look. An object moves 5 meters to the right in 3 seconds, then 11 meters to the left in 7 seconds, and finally 4 meters to the right in 3 seconds. Find the total travel time, the displacement, the distance traveled, the average velocity, and the average speed. So we have 5 questions here. Let us begin by drawing the situation, and the first step for that is choosing coordinates. All the motion happens along a line that we choose to be the x-axis. So this arrow here denotes the direction of my x-axis. The origin of the coordinate system will be somewhere here, so this corresponds to x equals 0. And I will draw a few markers denoting positive and negative values of x. 1, 2, 3, 4, 5, 6. And the same to the other side. 1, 2, 3, 4, 5, 6. That should be enough. Before we move any further, it is important to notice that this exercise has 3 parts. First, the object moves to the right, then moves to the left, and then it moves again to the right. But these 3 parts are very important to distinguish. So let's start with the first one. It says that the object moves 5 meters to the right in 3 seconds. So the object will start somewhere here in the origin, and it will move 5 meters to the right. That means 1, 2, 3, 4, 5. We'll end up here in x equals 5 meters. So the object will do this. It will move from left to right up to that point. And for this, it took a time that we can call t1. We know that the time is 3 seconds. That is the first part. In the second part, the object moved 11 meters to the left. So starting from point x equals 5 meters, it will end up in minus 6 meters. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this point here is x equal minus 6 meters. And here is where the object will end up in the second part here. And for this, it takes a time that we can call t2. Finally, it moves again to the right, but this time 4 meters. So starting from x equal minus 6, it will move 1, 2, 3, 4 to end up in the position x equal minus 2 meters. So the object will do this, left to right, 4 meters. And it takes a time that we can call t3. And that is the situation. This is our little cartoon or diagram of the situation. Now we can go and answer the questions. Part A says find the total travel time. This one is easy. We just need to sum the time for each part. So t total time will be t1 plus t2 plus t3, which is t1 was 3 seconds, t2 was 7 seconds, and t3 was again 3 seconds. So the total travel time was 13 seconds. That's it. Very easy. Total travel time is just the addition of the time for each step. Part B. Find the displacement. Because the displacement is a very interesting quantity in physics, and it denotes a vector, so that means it has a direction, and it also has a magnitude. So the magnitude of a vector is just the length of the arrow. The direction is where the arrow is pointing to, and in this case, we can visualize this clearly, because displacement, we can denote it with an x, we put a little arrow on top, is defined as the final position minus the initial position. So if we know these two quantities, we can find the displacement. The initial position was 0 because this is how we have chosen our coordinates. So I can simply put x initial here. It was at 0. And x final is this point. This is the final point. So this is x final. So we know that x final is minus 2 meters minus x initial, which is, well, 0 meters because that's the origin. So this is minus 2 meters. This is the vector displacement. So I want to make a few comments here. First of all, this definition has a representation in this diagram. It is given by an arrow that points from the initial point to the final point. This arrow here is our displacement. That is the meaning of this difference. Second, we notice three important quantities on the right-hand side here. We have meters, which is the units. I will mention this several times along this course, which is in physics, most quantities have units. If you give a result without units, it might not necessarily be wrong, but it will be incomplete. And you will find this also when you write your lab reports. Units are very important. If you have a table, you have to have units. If you have a graph, your axis must have units. It's extremely important. In this case, we have units of length in meters. Then we have a number 2 here. This is what we call the magnitude of the vector, basically the length of this vector. And third, we have this minus. The minus here is very important because it denotes the direction of the vector. Initially, we decided that our x-axis will point from left to right, and the fact that we have a minus indicates that our vector, displacement in this case, is pointing in the opposite direction, is pointing to the left, which is exactly what we see in the diagram. So that is the meaning of that minus. Alright, let's move on. Part C, find the distance traveled. Okay, this is very similar to part A, in which we just need to add the length of each arrow. So we can write the distance to be distance of the first part plus the distance of the second part plus the distance of the third part. In this case, in the first part the motion was 5 meters, in the second part was 11 meters, and the third part was 4 meters. This is equal to 20 meters. And that is the distance. Very simple. Important though is to notice the difference between distance and displacement. Distance has units, just as displacement, because in this case it's length, so it's meters. It has a magnitude, which is the number, but it has no direction. It's not a vector. This is what in physics we call an scalar quantity. Alright, part D. Find the average velocity. So average velocity sometimes is denoted with a little bar on top. It's also a vector and is given by the displacement divided by the total time. So we know the displacement is minus 2 meters divided by the total time, which is 13 seconds. Here we need to plug these numbers in our calculator. Minus 2 divided by 13. Minus 0.15. Let's write that. Minus 0.15. And here we have meter divided by second. This gives us the unit of velocity, which is meter per second. Again, we have a magnitude, the number, and we also have a direction. So the minus is also telling us that the velocity is pointing, in this case, to the left. This indicates that the object has moved from right to left, which is exactly what we see in our diagram. Part E. Average speed is not the same as average velocity. In fact, we can write average speed as simply the total distance traveled divided by the total time. For the total distance we found part C is 20 meters and the total time is again 13 seconds. Again, we plug these numbers in our calculator. 20 divided by 13 is 1.5. 1.5, once again, meters per second, because we have units of length divided by unit of time, that's meters per second. And that is the average speed. So the main point of this exercise is, first of all, to show you how to draw these diagrams, which are going to be extremely important, and we're going to use them in every single exercise. Always start by drawing a diagram, choose your coordinates, and then you have a picture of the situation. And from there, it will be very easy to write down equations. And the other part is that we stress the difference between displacement and distance. Displacement is a vector. It is an arrow that points from the initial point to the final point, whereas distance is just the length of the path that has been traveled. It's a scalar quantity, it's just a number with the corresponding unit. Whereas in the other case, we have average velocity and average speed. In the case of the average velocity, we use the displacement divided by total time, whereas in the average speed, we just use the distance divided by total time. In the next exercise, we're going to start a series of cases with trains that will move in different directions, trains that will pass each other, trains that will chase, etc. These are classic physics problems, so make sure that you don't miss that.